All right, so we just talked about the domains of our 6 trig functions, and I know they can seem overwhelming. However, I want to direct your attentions back to the previous page so we can make this make a little more sense. So let's go back here. So this was page 4, just the previous page, where we were finding our 6 trig functions of certain angles. So let's look at this one. T equals pi. We got sine of pi is 0, cosine of pi is -1, tangent of pi is 0, cosecant of pi is undefined. Well, does that make sense with the domain? Let's look at our domain for cosecant. All right, so cosecant is defined for all real numbers except multiples of pi. Well, pi is definitely a multiple of pi. That's why when you try to plug in pi into cosecant, you get something that's undefined. Same with cotangent. The domain of cotangent is everything except multiples of pi. That's why when you plug in pi into cotangent, you get something that's undefined. All right, so you can see the same with d, 5 pi over 2. We see that tangent is undefined. All right, let's go back and look at our domain for tangent. Tangent is defined for all real numbers except odd multiples of pi over 2. And we see when we plugged in an odd multiple of pi over 2 into tangent, we got something undefined. Same with secant. All right. Okay, so it helps to think about rewriting all of our trig functions in terms of sine and cosine, and that will help you figure out where they're undefined. Okay, so let's move on to some identities. All right, so one of the big important identities are the Pythagorean identity. And I will say, you do need to know all of these, but the most important one is sine squared of t plus cosine squared of t equals 1. And so these are called Pythagorean identities because they kind of look like the Pythagorean theorem, a squared plus b squared equals c squared. All right, and so this is a notation thing. So mathematicians have a particular way of writing trig functions when we're squaring them. Sine squared t, that actually means that we're taking all of sine of t and squaring the whole thing, right? Plus taking all of cosine of t and squaring the whole thing. All right, so these are the same. This is just kind of a shorter notation. All right, so we also have tangent squared t plus 1 equals secant squared t, and 1 plus cotangent squared t equals cosecant squared t. And so I can tell you that you really need to know how to memorize this, and I'll show you how to derive the other two in class. Okay, so you can use Pythagorean identities to help you solve certain problems. It makes life a little easier for us sometimes. All right, so it says, given that tangent of t equals 12 over 5 for some angle between pi and 3 pi over 2, use an appropriate identity to find the value of secant. All right, so one thing to notice is none of our numbers on the unit circle look like 12 over 5. All right, so the unit circle is not really going to help us here. However, we know we're on the unit circle. So let's talk about how we can work this problem out. Let's start with the first fact, is that t is an angle between pi and 3 pi over 2. Let's think about where that would be on our unit circle. All right, so I'm drawing a little mock unit circle over here where this is 0, pi over 2, pi, 3 pi over 2. This is a pi right here. Okay, so we want something between pi and 3 pi over 2. So we know our angle t is going to be somewhere over here in the third quadrant. Let's think about what that means. What do we know about x values in the third quadrant? So on the x-axis here, we should have negative values. So x is negative. And what about y? y values are also negative. So x and y are negative in the third quadrant. So we're going to use that to help us at the end of the problem. That was just a little setup. Going back to the problem, we see, oh, we have tangent, but we need to find secant. Is there a relationship that we can use between tangent and secant that could help us solve this problem? Well, we actually have a nice Pythagorean identity that relate both tangent and secant together. So we know that tangent of t squared plus 1 equals secant of t squared. Pythagorean identity. All right, now, do we know tangent of t? Yes, we do. It's 12 over 5. So how does this help us? Well, it helps us because we're trying to find a value for secant t. Now secant t is our only main variable in this problem. We can solve for secant t. All right, so I'm going to go ahead and simplify this side over here. So this should be 144 over 25. And I'm going to rewrite 1 as 25 over 25 because I know I'm going to have to add these two. All right, so when I add that, I get 169 over 25. And then I need to take the square root of both sides, right? Secant is squared. I'm trying to solve for secant, so I need to take the square root, remembering that when we do this, we could get a positive or a negative. Secant t could be positive or negative. So we're going to have positive or negative square root of 169 over 25 equals secant t. Okay. All right, I'm going to simplify this so it looks a little cleaner. Square root of 169 is 13 and square root of 25 is 5. All right, so plus or minus 13 over 5 is secant of t. Okay, how do we know which one that it is? Is it both? It's actually not going to be both. Okay, so we have to use other knowledge from the problem to figure out if our answer is positive 13 over 5 or if our answer is negative 13 over 5. The only other information we have is that our angle is between pi and 3 pi over 2, where we discovered both x and y are negative. All right, so I'm going to write something down. Remember that secant of t is the same as 1 over cosine of t, and we know cosine is the same thing as x, 1 over x. All right, and in quadrant 3 where we are, x is negative. So that means our secant is negative, which tells us that secant of t is negative 13 over 5 and not positive 13 over 5. All right, so think about how you feel about this. It was a lot of steps, a lot of logic being used, so make sure you rewatch this so you can understand what's happening here. We're going to do another example. I'm just going to do it in the next video.